Okay, so our goal today is to simplify expressions that contain radicals. Have you guys heard that term radical before? Okay. Radicals is just this symbol, so it just means a square root. It's a more generic term than using the word square root, though, because it allows us to also talk about cubic roots, fourth roots, fifth roots, things like that you will get into eventually when you take Algebra 2. For geometry, we only talk about square roots, but because I just am in the habit of it, I often refer to them still as radicals because, like I said, it's the more generic term. Okay? So, in order to simplify radicals, we first need to know what perfect squares are. So, perfect squares are the list that you guys made on the back of that square root sign. So we came up with 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. 10 squared is 100. Now, you guys did this all the way up to 30, so you guys know perfect squares up to 30. You have that list available to you. Okay, but just for the sake of our notes, we'll go up to 12. Those are the ones you should know in your head anyways. So our list of perfect squares then are these numbers right here. Our perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay. Those are perfect squares. What makes them perfect squares is that if I take the square root of 1, I get an answer. If I take the square root of 4, I get an answer. If I take the square root of 9, I get an answer. If you did a number that's not on our list, so we go from 9 up to 16. So if you take the square root of 12 in your calculator, it doesn't give you a nice answer. It gives you this decimal. Okay? But if you do the square root of 16, the nice answer is just 4. Okay? Can't see that, sorry. There you go. All right, that's what makes a perfect square, so that we can take the square root of it. So the first example that we're going to do is to simplify the radical. So the first one that we're going to do is the square root of 50. And I can see that 50 is not on my list. It falls between the 49 and the 64. So if I were to try to put that in my calculator, it's going to give me that it's 7.07106. Okay? Now, I want to write it in a simplified form. So what I'm going to have to do is I'm going to have to write this as a perfect square times a perfect square. So 50 can be broken down into what two numbers? You want to use a perfect square. So what's a number that's on my list here? 1, 4, 9, 16, 25, 36, 49, 64 would be too big. A number times another number. What is it? 25 times what? 25 times 2 will give me 50, right? And 25 is my list. It's on my list. 25 is right here on my list. So that's that good number. The property says that if you're taking a square root of two things that multiply, it's the same thing as taking the square root of 25 times the square root of 2. So you can take the square root of those numbers individually. Which then allows me to say, well, what is the square root of 25? 5. So the reason I picked a perfect square is because I know I'll be able to take the square root of it and I get an answer, a nice answer. So I have 5 square roots of 2. Okay. Now I came up with 25 because that's the largest perfect square that is a factor of 50. Now, remember I typed in the square root of 50 and it was something kind of nasty? And I got like 7.07. I can still use this to check, though, that my simplified answer, 5 times the square root of 2, is also that same value. That's how you can check to make sure I simplified it correctly, because I didn't change the value when I wrote the square root of 50 and I wrote 5 square roots of 2. Do you see that? How you can use your calculator still to check, but you can't use your calculator to get 5 square roots of 2. Your calculator is not going to tell you that answer. Okay. So, there are some calculators that do simplify radicals. I think, Connor, you might have one. I have one in here too. But if you have one of these, you're not allowed to use them on the test. So this one, I think, does it too. It actually tells you it's 5 square roots of 2. Okay. But if you had one of these, then you'd have to trade it for one of my purple calculators when the test happens, or a quiz. Does that make sense? All right. So the next one, we're going to try another one. So that was number 1. We'll try another one. Let's try the square root of 48. What's a number from our list that goes into 48? 16. So I can write this as the square root of 16 times the square root of what? 16 times what gets you 48? 3. Are we okay so far? What is the square root of 16? 4. So we now have 4 square roots of 3. I can double check this in my calculator. The square root of 48 is 6.928203. 4 square roots of 3 is the same value. That must be correct. Okay. Let me show you an error that many people make and how you know it's an error and how you can fix it. Are you ready? A lot of people don't know multiples of 16 in their head. So what they will see when they do this is they'll take the square root of 48 and they'll say, what's a perfect square that goes into 48 that they know in their head? And what do you think they say? 4. So they say the square root of 4 times the square root of 4 times what gets you 48? 12. Okay. So you end up with 2 square roots of 12, because the square root of 4 is 2, which is fine, because they'll even maybe check it in their calculator and say 2 square roots of 12. It's still 6.928, so I'm still getting the same value. Cool, that's correct. Okay? But you can look at this and know that it's not simplified. Does anyone can see why the square root of 12 is not simplified? Lucas? There is another perfect square that goes into 12. What's a perfect square that goes into 12? 4. So we have to break this down again. So we're going to leave the 2 out front. The square root of 12 is going to become the square root of 4 times 3, because 4 is that perfect square. Okay, I can take the square root of 4, so I have 2 times the square root of 3. And now I have to multiply the 2 and the 2 that are on the outside, and 2 times 2 is 4 square roots of 3. Notice that's exactly what I got over here, but it took me quite a few more steps. So how can you do it in the least amount of steps? Yes, take the biggest perfect square. So 4 worked, but double check that 9, 16, 25, 36, 49. Make sure those bigger numbers don't work too, because if there's a bigger number that will work, you'll want to go that route instead. Does that make sense? So let's try one more. Let's try the square root of 72. Let's see what you can break it down into. You can just start right with your list. So 72 divided by 1, that doesn't really help us because we're still at 72. 72 divided by 4, that's going to work, but let's see if we can have anything larger. Okay, so 72 divided by 9, that also works, but let's see if there's anything larger. How can you tell that there's going to be something larger if you have an 18 or an 8? Because I can tell by looking at the 18 and looking at the 8 that there will be a larger perfect square. There is another perfect square that goes into 18. 9 is a perfect square that goes into 18. So right from there, if I do divide by 4 and I get 18, oh no, a perfect square goes into 18. That must not be the largest. A perfect square also goes into 8. What's the perfect square that goes into 8? 4. So I can see that there must be something larger. So I keep going. 72 divided by 16, that doesn't work. 72 divided by 25 doesn't work. 72 divided by 36, 36 times 2 will get me 72. Right? That's how division works. It's the opposite of multiplication. I don't want to do 2. I want to pick numbers that are on my list. You want to do perfect squares. Because if it was like 2 and 20, that does nothing for you. Does that make sense? So you don't want to divide by numbers that are not 1, 4, 9, 16, 25, 36, 49, 64, 81, because you have to have a perfect square times another number. In this case, yes, if you were to divide by 2, it ends up being a perfect square, but we don't know that. Does that make sense? I'll show you another example after this. So 36 times 2. And I always write my perfect square out front, because once I take the square root of it, it no longer has a square root sign, and that's the number that goes out front. So what's the square root of 36? So we have 6 square roots of 2. Are we okay with that? So what I was saying is that if I had the square root of 40 and I just said this is the square root of 2 times the square root of 20, this is true because 2 times 20 does get you 40. But what's the square root of 2? If you take the square root of 2, you do not get a nice number. So that didn't help us. Can you take the square root of 20? You can, but that also doesn't help us. because we can't put these approximate values in here. So this throws us off because you can't do either of these. And so we're back up here at the square root of 40 and figuring out how to divide that up into two numbers. So the square root of 40, what would be a number? 16 goes into it? So 40 divided by 16, 16 doesn't go into it. Ends up being 2.5. Go ahead. 4 goes into it. So 4 times what? 10. What's the square root of 4? So we have 2 square roots of 10. Are there any perfect squares that go into 10? Nope, so we're done. And again, you can check it. You can do the square root of 40 and 2 square roots of 10 and make sure that they have the same value, which they do. So I must have simplified it correctly. And there's no perfect squares that go into 10, so I'm good. Does that make sense? Okay, so then what I'm going to do is I'm going to pass out your assignment, and we'll have you get started on it. We're not done with notes yet today, but we'll at least get to the simplifying part of them.